So I had the opportunity to see you do a corneal transplant to DMAC, and I'm very mesmerized by how thin the tissue is. And then when you insert it through the apparatus and into the cornea, and then it kind of folds into the inner layer of the cornea, it's kind of amazing. So I remember that you have developed some technology and also some apparatus specifically for these technology. Can you talk about them?
Yeah.
How do you develop these apparatus?
So when we were doing DSEC surgery started doing that back in 2007, the challenge was at that time period. So obviously very different challenges compared to penetrating capacity. So the challenge was, how do you get something that's 8 millimeters through a 5 millimeter incision, right?
Yeah.
I mean, that's a basic challenge, right? And stuff. And sometimes I think that when things are very early, you have to really just get a pen and piece of paper and just think about this from a very basic standpoint, right? You don't need to make it too complicated, right? And actually, sometimes speaking to your friends who are not ophthalmologists, just to brainstorm is actually quite a good idea.
Yeah.
And the challenge is, how do you get something that's 8 millimeters across through a 5 millimeter incision, right? And I don't know if you've ever seen, there's that in the UK, we have this thing where you get these old empty bottles of alcohol and they have a boat inside it.
Yeah, you have to get it out.
Yeah. So you always wonder, how did they get the boat in, right?
Yeah.
So I don't know if you've seen that, how they basically do that. And it's very clever, because what happens is actually the sails of the boat are actually able to lie flat.
Oh.
Right. And that's how you get it through the mouth of the bottle. And then when they put it inside, they erect the sails up. And that's how you get the mast in the side of the thing. So that's how they basically do it, right? So it's the same principle here. How do we get a transplant into the eye through a 5 millimeter or 4 millimeter incision that's actually 8 millimeters long? And that's why we developed the device there. And the device basically was the EndoGlide. So we made it back in 2008, 2009. It first went on sale, I think, in 2009. It was one of the first FDA-approved devices to do corneal transplantation. And that allowed you to deliver the tissue through the safety of a device itself, and allowed you to have the control to basically pull it inside the eye itself. Okay. And going through that experience, I did the wet lab stuff to understand the cell damage that was occurring. So we compared the cell damage with the current gold standard that was being done around the world, which is basically pulling it with forceps versus the device. And we were able to show that you almost had about 60% improvement in less cell damage with the device compared to what was achievable with forceps delivery. And then obviously we did patients and stuff, and the outcomes were good. So we knew that basically worked, and then subsequently we've been able to translate that with clinical studies to show that this was a massive advancement on basically doing the standard technique at that time back in 2009, which was basically the forceps and stuff.
Yeah.
So over the time, obviously, as DSEC then became more thinner, and then obviously went to DMEC, essentially what you saw was a newer version of that device. The first device is still obviously available on sale, the DSEC, but you saw a newer version where everything is much smaller, and it's designed for DMEC and stuff. And that goes through a 2.7 millimeter incision. But obviously, because DMEC is so fragile, like you said, with the device, I made special forceps. So instead of like 23 gauge forceps, I have 27 gauge forceps. I realized that when you pull the tissue inside the eye, even the fluid inside the anterior chamber can cause the graft to move around, because it's only 10 microns thick. So I redesigned the maintainer as well. So instead of having fluid coming straight down the side, the fluid goes up and down. So you maintain the chamber without having the graft move across the anterior chamber itself. So these little tricks and stuff, I mean, obviously it was to make the surgery easier, but not only for me, because for other people as well. So I thought, okay, if I find it a lot easier with this, then I'm sure other people will basically, find it quite easy to, find it a lot easier and stuff. And having those very fine forceps give you so much control, even though the tissue is only 15 microns thick. It then gives you the confidence to basically do the surgery. And at the end of the day, the role of developing these instruments was, for me, was to get more people to do a surgery that I think is great, and I think I believe in. And I thought, if I can make it easier, not only for myself, but make it easier for other people, surely more people are going to basically doing it. But, that's not the end of the task. The end of the task is then to publish papers through research, give lectures, to give courses and stuff, showing how to use this thing properly. And that's how you get people to basically start using this and stuff. And also being like, Vanessa, obviously, in Hong Kong, you came on a training course here and stuff, and then people email John, how can I get these forceps? How can I use? And and the thing is that if you see something, you think, okay, this is going to make it easier. there's no point keeping it a secret, right? I mean, at the end of the day, you want people to basically benefit from that as well. And you know, if they can benefit from that, that's great. And then obviously you can make these instruments and stuff. You know, then you then learn how to work with an instrument company. Can they make the thing? Of course, they benefit a lot because they put your name on these instruments, so they will earn a lot of money from this and stuff from getting these instruments. But at the end of the day, you just want to make something that you believe in or available for everybody.
Correct. I think the altruistic goal of developing new technology is just to help patients is very admirable. But on the flip side, people, or for general public perspective, when you talk about developing new technology or endoglide and even like commercialization of different medical equipment, and from a outsider view is thinking about, oh, you are a doctor, you shouldn't think about profit, you should about patient's best interest, you don't think about money. So how do you sort of persuade them or just say that, oh, what I'm doing is trying to help people, it's not about thinking about, oh, how much I can earn from this?